The strange reason time only moves one way. Time feels obvious until you question it. Moments pass, never return, and never pause. The future approaches, while the past quietly locks behind us. To understand why time only moves one way, we must strip away intuition. Clocks do not define time. Calendars do not create direction. For most of physics, time works perfectly in reverse. Equations allow past and future equally, yet our lives do not. You remember yesterday, not tomorrow. Causes come before effects. Spilled water never leaps back into a glass. Something enforces direction, and it is not the clock on your wall. For centuries, this puzzled scientists deeply. If physical laws allow reversal, why does experience not? Why does time feel like an arrow instead of a loop? Why does everything age, decay, and wear down? The answer hid in a quiet, invisible process. At first, time seemed fundamental, a constant river flowing forward. But physics revealed something unsettling. Time's direction is not built into laws. It emerges from conditions, from imbalance, from how motion spreads. Early in the universe, everything was compact and ordered. Energy was concentrated. Structure was tightly arranged. That starting point mattered more than anything else, because it set the direction for everything that followed. As the universe expanded, order began to loosen. Energy spread. Motion dispersed. Structure became harder to maintain. This spreading created a preferred direction, not for equations, but for reality. Your sense of time is built on memory. Memory requires change. Change requires irreversibility. And irreversibility comes from spreading motion. Time feels forward because disorder grows. At first, this seems abstract, but it shapes every experience you have. Why you age, why you heal slowly, why moments cannot be revisited. Time's arrow is written into how energy behaves. Yet this explanation raises deeper questions. If time's direction depends on spreading, what happens when spreading ends? If the universe reaches balance, does time still move at all? And if direction can emerge, could it ever reverse? Those questions pull us toward a far stranger understanding. To see why time feels irreversible, imagine a simple experiment. Drop a cup and watch it shatter. You instantly know the direction of time. The shards spread. Energy disperses. Order is lost. Now imagine the reverse. Shards leap upward. Heat gathers back into motion. The cup performs perfectly. Physics does not forbid this, but probability does. The laws allow reversal. The universe does not encourage it, because there are vastly more disordered states than ordered ones. Time flows toward what is most likely, and disorder is overwhelmingly likely. This makes time statistical, not absolute. Direction emerges from numbers, from counting possible arrangements. There are countless ways to be messy, very few ways to be neat. Time follows a crowd. This explains memory itself. You remember the past because it was more ordered. The present is less ordered. The future will be more disordered still. Memory cannot form toward chaos. It needs structure to record information. Even your brain obeys this rule. Thoughts consume energy. Neurons fire, releasing heat. Memories are written by increasing entropy. You cannot remember tomorrow because it has not paid that cost yet. At microscopic scales, time behaves differently. Particles collide and separate symmetrically. Quantum events do not care about direction. But when many particles act together, their probabilities align. Direction appears. This is why time feels smooth and relentless. It is not enforced by a clock. It is enforced by numbers, by the sheer imbalance between order and disorder. Once enough particles are involved, reversal becomes impossible. However, this raises a disturbing possibility. If time's arrow depends on entropy, then it could vanish. In perfect equilibrium, nothing changes. No memory forms. No direction exists. Time loses meaning. At equilibrium, physics still functions. Particles still move, but nothing interesting happens. No past, no future, just an eternal present. Time does not stop. It dissolves. This suggests something profound. Time is not a backdrop. It is a consequence. a side effect of a universe not yet settled. We feel time because the universe is unfinished, and that unfinished state defines our existence. This is where time becomes fragile, because its direction depends on special conditions. Remove those conditions, and the arrow fades. Early in the universe, entropy was astonishingly low. Energy was packed tightly. Structure was poised to unfold. That imbalance created a slope. Time began to roll downhill. But why did the universe start that way? Why was order so high at the beginning? Physics does not yet know. It is one of the deepest unanswered questions. Time's arrow rests on a mystery. Some theories suggest cosmic inflation smoothed everything. Others suggest deeper laws set initial conditions. Some propose many universes, each with different arrows. None offer certainty. Time's direction remained contingent, not guaranteed. This uncertainty leads to unsettling implications. If entropy defines time, then reversing entropy will reverse time's arrow. In theory, a region of decreasing entropy would experience time backward. Effects would precede causes. Memories would form from the future. Reality would feel inverted. Such regions are not forbidden. They are just unimaginably unlikely. The universe overwhelmingly favors spreading. Local reversals drown instantly in noise. Time's arrow is stable because probability protects it. Still, physics has observed tiny asymmetries. Certain particle decays violate time symmetry. They behave slightly differently forward than backward. These effects are subtle, but they suggest time's arrow may have deeper roots. Yet even these violations are too small to explain experience. They do not build memories. They do not age bodies. Entropy remains dominant. Statistics still rule direction. This makes time deeply personal. Your life follows entropy's gradient. Birth begins in order. Aging spreads complexity outward. Death marks equilibrium approaching. Time is not cruel. It is impartial. Every experience is shaped by this flow. Regret only makes sense facing one direction. Hope only points forward. Choice exists because futures are open. The past is locked by probability. Understanding this reframes existence. Time is not stealing moments. It is revealing them sequentially. Each moment exists because imbalance remains, because the universe is still unfolding. And that realization sets the stage for the final question. If time depends on entropy, what happens when the universe finally settles? When imbalance disappears completely? When nothing changes anymore? Does time end? Or was it never fundamental at all? The climax of this story is quietly unsettling. Time does not command the universe. The universe creates time. As long as energy spreads, time has direction. As long as imbalance exists, moments unfold. But when everything evens out, direction disappears. Not with a crash, but with indifference. In that far future, particles will still move. Motion will continue. But nothing meaningful will happen. No memory. No anticipation. No change worth noticing. Time will not stop. It will lose relevance. This changes how we see the present. Every second matters because it cannot repeat. Every choice matters because reversal is impossible. Time gives weight to action, meaning to consequence, value to now. You are not moving through time. You are shaped by its direction. Your thoughts, memories, and identity exist because entropy increases, because the universe is unfinished, because order still collapses into possibility. Time is not an enemy. It is a condition, a byproduct of a universe still becoming itself. When change ends, time fades with it. Until then, every moment is rare. Physics does not say time will end tomorrow. It says time is temporary. And that truth makes the present extraordinary. We live inside a window where direction exists, where stories can unfold, where choices can matter. Understanding this does not steal wonder. It sharpens it, because nothing about now is guaranteed. Not time, not memory, not you. So what do you think? Are we repeating the same mistake again? The strange